This is guided kinematic number 3. A driver of a car traveling at 15 meters per second applies the brakes, causing a uniform deceleration of -2 meters per second squared and slows to a speed of 2 meters per second. How far has the car moved during the braking period? So the first thing we need to do is visualize the problem. There's my lovely car traveling at 15 meters per second, and its acceleration is equal to -2 meters per second squared. And when it travels a bit, it slowed down to a speed of 2 meters per second. Just wanted to zoom in there a little bit. All right, this is a certain distance. Next, we need to see if we need to convert anything. And it looks like everything is in correct units, so we do not need to convert anything. Next, we need to write down our knowns and our unknowns. So this is going to be our initial speed. Our initial position is going to be 0. We do not know our final position. Here is our acceleration. And our final speed is 2. All right, so we have our knowns and our unknowns. So next we have to figure out which kinematic equation we want to use. So we have our initial speed. We have our initial speed, we have our final speed, we have our acceleration. We don't have time, so it looks like we don't want to use this equation. Maybe we can go back to it. Let's see, for this one, we don't have our initial position. That's what or our final position. Remember, our final position is what we're looking for. We're looking for how far the car has moved. So basically, if we know the initial position, then we would be looking for the final position. So let's go back to that second kinematic. We have our final position, or we're looking for our final position. We have our initial position, we have our initial speed, we have our acceleration, but we don't have the time. So it looks like we don't want to use that one either. What about kinematic number 3? So we have our final speed, it's that 2. We have our initial speed, it's that 15. We have our acceleration. We're looking for XF, our final position, and we have our initial position. So in this equation, we only have one variable to solve for, so it looks like this is the equation we want to use. So let's write that down. All right, what do we want to plug in for VF? We want to plug in 2. Don't forget to square. VI is 15. Our acceleration is -2. Don't drop your negatives. XF is what we're looking for, so we leave that as a variable. And XI is 0. All right, then we just have to chug through the algebra. We're solving for XF. So 2 squared is 4. 15 squared is 225. Remember, this term just goes away, so we end up with -4 times XF. Then I'm going to subtract 225 from both sides. And if I divide both sides by -4, I get XF is equal to 55.25. So we still need to put in our units. Now this is position. The correct units for position are meters, so we write meters, and we circle our final answer.